Okay, so they give us a bit of a softball derivative to do here, and I'm going to do this two different ways because we have a message for you here. First, I will do this with the quotient rule, which says the derivative is the bottom times derivative of the top minus the top times the derivative of the bottom, which is simply 1 in this case. We get 1x to the 0, and then the minus 5 has a derivative of 0, all over the bottom squared. And if we clean that up, we get 6x cubed minus 30x squared minus 2x cubed, all over, no change in the denominator. 6x cubed, and then you lose 2 of them, so we're down to 4x cubed minus 30x squared all over x minus 5 all squared. Okay, so that's pretty much finished, and that's what happens when we run the quotient rule. Now, what we want to show you here is if you really hated the quotient rule, it is 100% avoidable because anything that is a quotient can be rewritten as a product of a reciprocal. If you have 2x cubed over x minus 5 like this, you can write that as 2x cubed times x minus 5 to the minus 1, because this means 1 over x minus 5, and the product of those two things is exactly our f of x. Once you're in this form, it's not a quotient anymore, it's a product. And I claim that when I do the derivative this way, I'm going to get the same result as before. Let's see if it's true. If we do this with the product rule, you remember it's first d second plus second d first. So we get first, there it is. Oop. Bit of a pen glitch, but I think we're back now. So we get first times derivative of the second, which would be minus 1 x minus 5 to the minus 2. First d second plus second, that's x minus 5 to the minus 1, d first, which would be 6x squared. Just barely going to fit that in. Okay, can we clean that up at all? In this first term, we can multiply the minus 1 by our 2x cubed. That helps ever so slightly. And because we want this to end up looking like a fraction, so we can compare it with the quotient version, I'm actually going to write this as a fraction. Instead of x minus 5 to the minus 2, let's bring it back to x minus 5 squared. Then for this next term, we have 6x squared over x minus 5 to the 1. Now, if we want to combine these, because we're trying to end up with something that's just a single fraction, we need a common denominator. And the common denominator will be x minus 5 squared. This fraction has 2 of them, so they must both have 2 of them. So this first fraction's all right. This second one, we need a second x to the x minus 5 in it. So we'll multiply the denominator by x minus 5. And to keep things fair, we multiply the numerator by x minus 5 also. So after we do that, we have our minus 2x cubed. This part's just going to sit here for a while. All the action will be in the second term. And for this term, we have x minus 5 all squared. We get 6x squared times x. And we get 6x squared times minus 5. Now that these have a common denominator, we can add them up, and we get minus 2x cubed plus 6x cubed is going to be 4x cubed. Then we're going to get minus 30x squared. And the denominator is x minus 5 all squared. So it turns out it's kind of a matter of preference whether you deal with expressions like this using the quotient rule or the product rule. As you can see, they took about the same number of steps. It's just a matter of which one you find more comfortable. You can get equivalent answers either way.